Hello, welcome to Grey Matter Academics for the solution sessions. At the outset, I would like to wish you all a very happy New Year 2014. The topic, the solutions for the topic under consideration is probability and expected value. Now, to have a brief idea about probability, it is nothing but the favorable, it is nothing but the ratio of between favorable outcomes for a particular occurrence of an event and divided by the total number of possible outcomes. That is, it is nothing but the chance of occurrence in a total gamut of a sample of any event. Uh, First question, it says 4 coins are tossed. We need to find the probability that are exactly 2 heads is given by a standard formula. uh, Actually, we work out like this. We know that 4 coins are tossed. 4 coins are tossed, and probability of getting exactly 2 heads is given by the standard binomial formula, that is 4c2 into half, that is power 2. In out of 4 coins, we need getting exactly 2 heads, means the occurrence of 2 tails is also there out of 4 options. So it is governed by this formula 4c2 half power 2 into half power 2, which is equal to 4 into 3 by 2 into 1 into 1 by 4 squared, which is equal to 3 by 8. So the answer is option C. When we go to our PowerPoint presentation, it says option C, which is 3 by 8. Second question, A, B, C are mutually exclusive and exhaustive events such that P of A, that is probability of A, equal to twice the probability of B equal to thrice the probability of C. We need to find probability of B. Now, given A, B, C are mutually exclusive, it implies that A intersection B is null, so also B intersection C and A intersection C. All these 3 options are all null. Now, also it is given A, B, C are exhaustive, that is A union B union C is equal to the total sample space S. Therefore, probability of A plus probability of B plus probability of C is equal to probability of S, which is equal to 1. Now, given that probability of the occurrence of event A is equal to twice P of B equal to thrice P of C, and let us take that P of A to be equal to X. Therefore, P of B works out as P of B equal to half of X by 2, and P of C will work out to X by 3, 1/3 of P of A, which is X by 3. Now, replacing P of A, P of B, P of C in terms of X, we get 11X by 6 equal to 1. Now, we have X equal to 6 by 11. But we know P of B is half of X. So therefore, the probability of the occurrence of event B is equal to 3 by 11, or option D. Moving over to a PowerPoint presentation, so the option is D, which says 3 by 11. Question 3. The probability that A and B solving a problem in statistics are 1 by 2 and 3 by 5 respectively. A problem is given to both A and B. The probability that neither of them solves the problem. Going to our work area, given that the probability of solving a problem by A is 1 by 2 and by B is 3 by 5. So the probability of A not solving the problem is 1 minus half, which is also 1 by 2. So also the probability of B not solving the problem is 1 minus 3 by 5, which is 2 by 5. Now it is required to find the probability of both of them not solving the problem, neither of them solving the problem, which is equal to half into 2 by 5, that is PA bar into PB bar, which is equal to half into 2 by 5, which is equal to 1 by 5, and that's nothing but an option C. Going to our PowerPoint presentation, it is option C, which says 1 by 5. Fourth problem, in a group of students, 30% failed in economics and 40% failed in mathematics and 50% failed in both. The probability that a student selected has passed in mathematics, given that he has passed in economics. Going to our worksheet, let us take A be the event where the students who have passed in economics. Since students who have failed in economics is given to be 30%, so the students who have passed in economics, that is probability of A is 1 minus 30 by 100, which is 70 by 100. Similarly, if we take B to be the event where students who have passed in mathematics, P of B will be equal to, given that students who have failed in mathematics to be 40%, so the students who have passed in mathematics would be 1 minus 40%, 40 by 100, which is 60 by 100. Also, it is given that students who have failed in both the subject to be 50%. So the students who have failed, who have passed, that is A intersection B, would be 50 by 100. Now conditional probability is given as probability of the event B to occur given that A has occurred. Now P of A intersection B by P of A will be the conditional probability of P of B by A, which is equal to 50 by 100 divided by whole divided by 70 by 100, which is 5 by 7. So the answer is option C. Going to our PowerPoint presentation, it is option C, which says 5 by 7. Moving on to fifth question. A bag contains 20, 30 and 50 1 rupee coin, 2 rupees coin and 5 rupees coins respectively. If two coins are drawn, the probability that they are one each of rupees 2 and rupees 5 coins. We need to calculate the probability of that. So getting back to our work area as listed here. Now total coins is equal to 100. Now we need to find probability of 1 rupee of 1 rupees 2 and 1 rupees 5 coin need to be selected. What is the probability of that? The simple way of working is either you pick up first as 1 rupees 2 coin, and then you pick up probability of picking up of 1 5 rupees coin, or the other way, first you pick up, that is the probability of having picked up the first coin to be a rupee 5, and then the second coin, the probability of picking 1 rupee 2 coin, which is also written as that is, there are 30 2 rupee coins, so to pick 1 2 rupee coin it is 30 C1, and to pick 1 5 rupee coin out of 50 coins is 50 C1, and the total coins picked up being 2 out of 100 coins, so the actual probability also works out as 30 C1 into 50 C1 by 100 C2 is equal to, after all simplification, you get 10 by 33. So the answer is option C. Going back to our PowerPoint presentation, it is option C, which says 10 by 33 as shown in our working. Going to the sixth question, given that the probability of A equal to 2 by 5, probability of B equal to 1 by 4, probability of A union B is 3 by 5, we need to find the probability of A intersection B. Looking at the work area, these are the given parameters. We know that P of A intersection B is given by the formula P of A plus P of B minus P of A union B. We need to compute probability of A intersection B. So inserting the relevant values, it works out to be 1 by 20. So the option is A. Going to our PowerPoint presentation, it is option A, which says P of A intersection B is the A option, which is 1 by 20. Seventh problem, the odds in favor of two mutually exclusive events are 2:5 and 3:7. The probability that at least one of two events to occur. Going to our PowerPoint, the work area, it's given both the events are mutually exclusive, which implies P of A intersection B is 0. Hence, P of A union B is equal to P probability of A plus probability of B, because P of A intersection B is 0. Now probability of A is equal to 2 by 7, probability of B is 3 by 10. So substituting the relevant values, we work out as 41 by 70. So the answer is option C. When we go to our PowerPoint presentation, it is option C, which is 41 by 70. Now, eighth question, it reads as, if x is a continuous random variable with probability distribution function, f of x is given to be this, c by x squared from 2 to infinity, otherwise it is 0. We need to compute the value of c. Going to our work area, as mentioned, we know that since x is a random variable and continuous random variable, and PD, that is the probability distribution function, is given by this as given the question. Now we know that if you try to integrate from minus infinity to infinity of f of x dx, that then we get as 1. So this we can rewrite from minus infinity to with the function f of x dx plus 2 to infinity f of x dx. From minus infinity to, since f of x is 0, the integral, the definite limit will also be 0 here, and from 2 to infinity c by x squared dx, on integrating we'll get minus c by x from 2 to infinity equal to 1, which is given, which is known generally. So when we work out, we get the value for c as 2. So the answer is option B. Going to our PowerPoint presentation, it is B option, which says it c equal to 2. Ninth question, a person buys a lottery ticket for rupees 10. If he wins, he will get rupees 1000, and the probability for the same is 3 by 10. We need to calculate the expected amount of his gain. Now going to the work area, we know that, let us take A as an event, winning a lottery of rupees 1000 when he buys the lottery for rupees 10. Now the probability of winning 1000 rupees is 3 by 10 and losing is 7 by 10. That is P of A bar. Now if we have to find the expectation of winning, then it is 1000 into 3 by 10, which is 300. But what we want now is expectation of gaining the whatever is the gain, rather expectation of the gain. which is nothing but gain of A into probability of winning plus loss amount into the probability of losing. We know that gain of A would be 990 rupees because he buys for 10 rupees, and if he gains he would, I mean, if he wins he gets 1000, so gain would be 990. Probability of winning is 3 by 10, whereas that is also added with, if he were to lose, then he has to lose minus 10. That is 10 rupees he would have lost, which we represent as minus 10. The probability of losing is 7 by 10. So his expectation of gaining is 290. So the answer is option A. Going to our PowerPoint presentation, it is option A, which reads as rupees 290. The expected amount of his gain, the expectation of his gain rather, is 290. 10th question, a random variable x has the following probability distribution. As shown, we need to find the expectation of 2x plus 5. Going to our work area, the distribution with the random variable, discrete random variable, and the corresponding probability distribution is shown. Now we know that expectation of x is equal to sigma xi into pi, the corresponding probability. So now expectation of 2x plus 5 is, as per the property of expectation, it is 2 into expectation of x plus 5. Now 2 into, when we substitute the corresponding value for minus 2, it is 1 by 3 minus 2 into 1 by 3 plus 3 into 1 by 2 plus 1 into 1 by 6 as shown in the table, plus 5. On simplification, we get the answer as 7, which is nothing but option C. Going to our PowerPoint presentation, so expectation of 2x plus 5 based on the given probability distribution of the random variable, discrete distribution sort of thing, would be option C, which is nothing but 7, a value of 7. 11th question, the wages of 8 workers in rupees are 62, 50, 70, 40, 54, 45, 32 and 47. If one of the worker is chosen at random, the probability that his wage is above the average is, going to our work area, we find the arithmetic mean or the x bar is computed as follows. You add all the wages, that is of 8 workers, and we find that the arithmetic mean is 50. It is asked that if you pick a worker at random whose age is above wage is above the arithmetic mean, above the average, that is given by the notation probability of A greater than x bar, then we find there are 3 people who are above. So the favorable occurrences is 3, that is there are 3 out of total number of 8 workers. So the answer is 3 by 8, or option is B, which is nothing but, as shown in our PowerPoint, it is B, which is 3 by 8. 12th question, a bag contains 3 white balls, 4 red and 5 black balls. 3 balls are drawn at random. The probability that they are of each color is worked out as follows. Given these things, 3 white, 4 red and 5 black balls. Now probability of picking picking 3 balls such that each one represents one color. So that is probability of 1 white, 1 red and 1 black is given by 5c1 into 4c1 into 5c1. That is picking one white ball from 3 white balls, picking one red ball from 4 red balls, and picking one black balls from 5 out of the total number of balls being 12, we need to pick 3 balls. So when we compute and simplify, we get the answer as 3 by 11. So the answer is option A. Going to our PowerPoint presentation, it is option A, which is 3 by 11. 13th problem, the probabilities of A and B winning in a race are 1 by 6 and 1 by 3 respectively. If the probabilities of A and B are mutually exclusive, then the probability of A or B winning is worked out as follows. Given the data as follows. Now also it is given A and B are mutually exclusive. That is, it implies that probability of A intersection B would be 0. Therefore probability of A union B, that is either A or B winning, would be equal to probability of A plus probability of B only. So it works out to be 1 by 6 plus 1 by 3, which narrows down to 1 by 2. So the answer is option C. Going to our PowerPoint presentation, it is option C, which says 1 by 2. 14th question, if two events are mutually exclusively, they cannot be independent. That is, the very definition of mutually exclusive means if out of the two events or any number of events, if one occurs, then the other won't occur, and vice versa. If other occurs, the earlier one will not occur. So they cannot be independent. So the answer is option C, which says they cannot be independent. So option C, which says not in, or that is independent events. So they cannot be independent events. 15th question, which pair forms a set of exclusive and exhaustive events? If we go through all the options, using our work area, in the first option is the correct answer, because it says the first sentence of that option A says you have to choosing multiples of 2. So the probability of choosing multiple from a die is multiples of 2 would be 3 by 6, that is 1 by 2, whereas probability of selecting, probability of an odd number falling is also 3 by 6, which is 1 by 2. Now mutually exclusive means, that is, the occurrence of A will not lead to the occurrence of B, and they are also not independent. So the probability of A intersection B is 0, and exhaustive means the probability of occurrence of A plus or probability of B, when you add the total sum, it works out to be the total sample space probability, that is 1. So the only option is A. So going to our PowerPoint presentation, we see option A should be the answer, while B, C and D does not satisfy both exclusiveness and exhaustive events. So answer is option A, which says choosing a multiple of 2 and choosing an odd number when a die is thrown. Question 16, a sure event is, out of the 4 options, the entire sample space itself, while all others don't concur to that statement. A sure event is, okay, so the option is C, which says the sample space itself. 17th question, if two events are independent, they cannot be mutually exclusive. That is, both the events can occur simultaneously because they are independent, unlike a mutually exclusive event. So the answer is option A, which says mutually exclusive. 18th question, a random variable can take, out of the 4 options, it can take any real number value. So the option is D option, which says any real number. 19th question, if probability if p of x is the probability mass function of discrete random variable, then the answer should be B option, which says p of x is greater than or equal to 0, because probability of any random variable x will be always greater than or equal to 0. And since being a discrete, it should be sigma x of p of x should be equal to 1. So it is a B option, which says p of x is greater than or equal to 0 and sigma of x, p of x is equal to 1. So the answer is B option. 20th question. If x and y are independent random variables, then the expectation of x into y is equal to expectation of x into expectation of y. This is the only option which is applicable for x and y being independent random variables. So the answer is C option, which says expectation of x into y is equal to expectation of x into expectation of y. So C option. 21st problem. If probability of A is twice probability of B and A and B are given to be mutually exclusive and exhaustive, we need to compute probability of A. Going to our work area, P of A is equal to twice P of B equal to A. That means P of A is equal to, if you say P of A is small a, then P of B would be A by 2. Since it is given as mutually exclusive and exhaustive, we have that P of A intersection B is 0 and P of A plus P of B equal to 1. That is A plus A by 2. Replace P of A by A and P of B by A by 2. We get A plus A by 2 equal to 1 or A equal to 2 by 3. That means probability of the event A, which is given by small a, is equal to 2 by 3. So the answer is option A. Going to our PowerPoint presentation, it is option A, which is 2 by 3. 22nd problem, we need to compute the probability of A prime union B prime. We know, as per going to our worksheet area, we know from De Morgan's law, A prime union B prime is nothing but A intersection B whole prime, complement of that. That means probability of that would be equal to, probability of A complement A union complement B is equal to probability of A intersection B complement, whole complement. Again, going by the laws of probability, it will be equal to 1 minus probability of A intersection B. So the answer is option B. Going to our PowerPoint, it is B option, which is 1 minus probability of A intersection B. 23rd question. If A and B are dependent events, then B option is the only right option, because probability of A intersection B cannot be equal to probability of A into probability of B. So it is a B option, which says probability of A intersection B not equal to probability of A into probability of B when they are dependent. Only when they are independent, this will hold good. So it is B option is the answer for the given question. 24th question. The standard deviation of a random variable can take non-negative values only. This is as per the definition of variance in expectation. So the option is C, which says can take non-negative values. 25th question. When two dice are thrown, the probability that the product is either 2 or 3 or 4 is worked out as follows. Now, probability of product A equal to 2 is, there are two options. One 2 or 2 1, that is 2 by 36. Similarly for product B, that is to get a product of 3 by throwing 2 dice, would be again 2 by 36, because when you throw 2 dice, the total possible events are 36, 6 into 6. Out of that, 2 options will come, that is 1 in 3 or 3 in 1, to give a product of 3. Similarly for product C, which should give equal to 4, you have 1 4 or 2 2 or 4 1 from 2 dice. So now the product of either 2 probability of the occurrence of the product being either 2 or 3 or 4 is, since the events are all mutually exclusive and part of an exhaustive thing, so the intersection aspect doesn't come, so we have to straight away add the probability. So 2 by 36 plus 2 by 36 plus 3 by 36, which works out to be 7 by 36. So the answer is option C. Going to our PowerPoint presentation, which is option C, which says 7 by 36. 26th problem, the probability that A speaks truth is 0.7 and the probability that B speaks truth is 0.3. We need to find the probability that they contradict one another is a specific case, and we need to find out the probability of one contradicting the other. Now, given probability of A speaking the truth is 7 by 10 and probability of B speaking the truth is 3 by 10. So probability of one contradicting the other. So it will be when A speaks truth, B should speak lies. That is P, and vice versa. So probability of A into probability of B bar, that is he should speak lies, probability of speaking lies by B, plus the other option is when A speaks lies, that is probability of A bar into, and when B speaks truth, into probability of B, which is 7 by 10 into 7 by 10 plus 3 by 10 into 3 by 10. So it is 58 by 100, which is 0.58. Going to our PowerPoint presentation, it is option A, which is 0.58. 27th problem, a sample of 100 contains 10% defectives and another of sample of 100 contains 5% defective. If one item is chosen from each, what is the probability that they are non-defective? Let us take the first sample A having 100 items and the second sample B with 100 items. The probability of selecting from the first set A to be defective is 10% or 10 by 100, and in the second set B with 100 items there is a 5% defectiveness, that is 5 by 100. Now we want to find probability of non-defective, that is either you select if one item is chosen from each, suppose, so to be non-defective the probability of from the A set would be 90 by 100, and since they are independent, if we select one non-defective item from a set B, it will be 95 by 100. So the effective selection of one defective from the first set and the second set would be 855 by 1000, which is 0.855. So the option is C. Going to our PowerPoint presentation, it is option C, which says 0.855. 28th problem, if A, B, C are mutually exclusive and also exhaustive events such that P of A equal to 2 twice P of B equal to thrice P of C, as per the worksheet, rather work area, A, B, C are given to be exclusive and exhaustive. This means P of A plus P of B plus P of C equal to 1. Given that P of A equal to 2 twice P of B equal to thrice P of C, let me take P of A equal to X, because we need to compute P of A. That then X plus, replace the corresponding things, the probability of A, B and C respectively with the in terms of X. So you get X plus X by 2 plus X by 3 equal to 1. So when we add and we calculate X, which is the probability of A which is required, works out to be 6 by 11. So the option is C. Go to our PowerPoint presentation. It says the C option, which is 6 by 11. 29th question. The odds in favor of a student passing a test is 3:7. The odds against another student passing a test is 3:5. The probability that both will pass in a test. Now, that is student A, the odds in favor of passing is given to be 3:7. Now, so the probability of student A or event A passing is given by 3 divided by the total odds in favor and against, that is 3 plus 7. So 3 by 10 is the event for the student A to pass, the probability. And now for the event B, that is the student B, odds against is given as other student passing, odds against other student passing is given to be 3:5, or the probability of this other student passing would be other way, that is 5 by, because it is against, now we have to see favor, it will be 5:3, so it will be 5 by 5 plus 3, so it is 5 by 8. Now the probability of both passing is given by, since they are independent events, so it's probability of A into probability of B, which is 3 by 10 into 5 by 10, which works out to be 3 by 16. So the answer is option A. So it is as shown in the PowerPoint, it is option A, which is 3 by 16. 30th question. If the variance of x is given to be 15, then the variance of 3x plus 5 need to be computed. Going to our worksheet. Variance of x as mentioned is 15. Now variance of 3x plus 5, using the property and the characteristics of variance, it is nothing but 3 squared into variance of x, which works out to be 135. So the answer is option B. Going to our PowerPoint presentation, it is option B, which says 135. 31st problem. In a class, 30% of students study mathematics and 20% study accounts and 5% both. A student is chosen at random. If it is known that he studies accounts, the probability that he studies maths, going to our work area, now we define A as a student studying, event A as student studying maths, B as student study accounts. Now probability of A is given to be 30 by 100, probability of B is given to be 20 by 100. Also probability of student studying both, that is A intersection B, is given to be 5 by 100. We need to evaluate that what is the probability of students studying maths, given that they study accounts, is nothing but a conditional probability condition, where this probability is evaluated as P of A intersection B divided by P of B, which is 5 by 100 by 20 by 100, which is 1 by 4. So the answer is option C. Going to our PowerPoint presentation, it is C option, which is 1 by 4. 32nd problem. If P of A is half, P of B is 1 by 3, and A and B are independent, then we need to compute P of A union B. that is probability of A union B. So given these inputs and A and B being independent, so P of A union B will be P of A plus P of B minus P of A intersection B would work out to as P of A into P of B. Substituting these values and simplifying, we get the answer as 2 by 3. So the answer is option A. Option A. Going to our PowerPoint presentation, it is option A which says it is 2 by 3. 33rd problem. When a die is rolled 4 times, the probability that there will be at least one 5 is worked out as follows. The number of rolls, number of times the die is rolled is n equal to 4. Now, whenever a die is rolled, a probability of getting a 5 in one roll, that is p, small p, will be equal to probability of getting a 5 in one roll, is because it is an unbiased die, so 1 out of 6, that is 1 by 6. Now probability of getting at least one 5 in rolling a die for 4 times. At least one 5 means that is probability of your random variable x greater than or equal to 1 would be 1 minus probability of x equal to 0. You subtract from 1 the case when you roll a die 4 times and you never get a 5. So that is given by that Bernoulli's theorem, which says 4c r into 1 by 6 whole power r into 5 by 6 whole power n minus r. So in this case it is 1 minus, since none of the times out of the 4 times you get a 5, means it will be 4c naught into 1 by 6 whole power 0 into 5 by 6 whole power 4. That will work out to, and when you subtract from the total probability, you get at least once a 5 when you roll it for 4 times. So the answer is 1 minus 5 by 6 whole power 4, or the option is D. Going to our PowerPoint presentation, it is D option, which says 1 minus 5 by 6 whole power 4. 34th question. If two random variables are connected by the relation y equal to 3x plus 4y plus 7 equal to, now the ratio of the standard deviation of x and standard deviation of y is worked out as follows. 3x plus 4y plus 7 equal to 0 means y is equal to minus 3 by 4, x minus 7 by 4. Now variance of y would be equal to, as per the characteristics of variance of a linear equation, will be minus 3 by 4 whole squared variance of x. Similarly, variance of x will be minus 4 by 3 whole squared of y. So variance of x by variance of y would be 4 by 3 whole squared, or variance being the square of standard deviation, so it will be the square root of variance would be the standard deviation. So sigma x by sigma y, or standard deviation of x is to standard deviation of y, is equal to 4:3, which is option B. Answer, going to PowerPoint presentation, it is B option, which says 4:3. 35th question. If a die is rolled once, the odds in favor of getting a multiple of 3. Going to our work area, in a die, the set consisting of multiple of 3 occurring would be, the multiple of 3 would be 3, 6 is the set. Now odds in favor of multiples of 3 occurring in a die is twice. There are 2 options for a multiple of 3 to occur in a unbiased die, and there are 4 options for a number not to be a multiple of 3. So the ratio, that is odds in favor of multiple of 3 in a die, would be 2 is to 4, or that is 1 is to 2. So the option is C. Going to our PowerPoint presentation, if a die which is C option, which is 1 is to 2. 36th question, if x is a random variable with mean A and standard deviation B, then the mean and standard deviation of x minus A by B is worked out as follows. Mean or expectation of x is given to be A, standard deviation is given to be B. Now expectation of x minus A by B is, as per the general property, is nothing but expectation of x minus A whole divided by B. Now A minus A, now expectation of x is A, and then minus A, which is the thing, by B, which is equal to 0. Now we, instead of computing standard deviation directly, we go through calculation of variance of x minus A by B, which is equal to 1 by B squared to variance of x. Now standard deviation is given to be as B, means of x, so variance of x would be B squared. So variance of x minus A by B was 1, so standard deviation of x minus A by B would be variance, square root of variance of x minus A by B, which is equal to 1. So the answer is option A. Going to our PowerPoint presentation, it is option A, which says 0 is the mean and 1 is the standard deviation of the function x minus A by B. 37th problem, 3 dice are thrown. The expected value of the product of the 3 numbers is, if a die is thrown, the expectation would be worked out to be 7 by 2. If a single die is thrown, the expectation would work out to be sigma xi into pi, which works out to be 7 by 2. And to generalize this, when n dice are thrown, the expectation of the product of numbers is calculated, can be taken as 7 by 2 whole power n. Hence, when 3 dice are rolled, expectation of the product of numbers will be equal to 7 by 2 whole power 3. So the answer is option B. Going to our PowerPoint presentation, it is B option, which says 7 by 2 whole power 3, or 7 by 2 whole cube. Now 38th problem, n dice are thrown, the expected value of the product of the numbers. If you see the previous problem work area, as told, if it is a single die, means you get 7 by 2, and in generalized case, when n dice are thrown, so the expected value of the product of the numbers would be given by 7 by 2 whole power n, which was already explained in the earlier slide. So the answer is, as per PowerPoint presentation, should be A option, which says 7 by 2 whole power n. 39th problem, if x is a random variable, the probability function as given in the question, we need to compute the value of k. Going back to our work area, worksheet, as per the distribution and the corresponding probability. Now we know that summation of all the individual probability should be equal to 1. So that works out to be 10k equal to 1, or k will be worked out as 1 by 10. So the option is C. Going to our PowerPoint presentation, it is C option, which says value of k is 1 by 10. 40th question, if x is a continuous random variable with probability distribution function f of x given by this, the value of k need to be computed. Going to our worksheet as given, we know in a probability distribution function, the random variable x, a continuous one, integral minus infinity to infinity f of x dx is equal to 1. Now here minus infinity to infinity f of x dx equal to 1 can be split as minus infinity to 0 and then 0 to 1 and 1 to infinity. uh, Minus infinity to 0 would fetch only 0 because f of x is defined as 0. So also from 1 to infinity, so after integration also you get 0. So the only thing we need to integrate is from 0 to 1 k f of x dx, and f of x is given as kx in that range from 0 to 1. So it boils down to kx squared by 2 with 0 to 1 limit equal to 2 1. So k will be worked out as 2. So the option is B. Going to our PowerPoint presentation, it is B option. So the value of k is worked out to be 2. 41st problem, if two dice are thrown, the probability that the sum of the numbers is greater than 5 is worked out in the work area. Two dice are thrown, the sum of the values should be greater than 5. This has been shown as 1, 5, 1, 6, etc. And similarly, you also include 6, 1, 6, 2 also. So 2, 4 means 4, 2 should also come. With all the options displayed, the probability would be for a sum of the value to be greater than 5 for two dice being thrown, 26 by 36, which is 13 by 18. So it is option B. If you go to the PowerPoint presentation, it is option B, which is 13 by 8. 42nd problem, A and B are two events such that P of probability of A is 2 by 3, probability of B is 1 by 4, and probability of A intersection B is 1 by 32. Then conditional probability of A bar B, that's conditional probability. Given that B has occurred, what is the probability of A? Going back to our work area, P of A is given to be 2 by 3, P of B is given to be 1 by 4, P of A B is given to be 1 by 32. Conditional probability of A bar B is equal to probability of A intersection B by probability of B, which is 1 by 32 by 1 by 4, which is 1 by 8. So it is option A. Going to our PowerPoint presentation, it is option A, which is 1 by 8. 43rd problem, the odds in favor of India winning against Pakistan is 4:3. We need to find the probability that India will win in a match against Pakistan. Now odds in favor of India winning against Pakistan is given to be 4:3. Now probability of India winning against Pakistan is given by 4 divided by the sum of the elements of the ratio given, that is 4 and 3. So 4 by 7. So the probability of India winning against Pakistan, a match against Pakistan, is 4 by 7. So it is option C. Going to our PowerPoint presentation, it is option C, which is 4 by 7. 44th question, an impossible event is an event containing no elementary events. This is as per the definition of impossible events. So the option is A, which is event containing no elementary events. 45th question, which set of events form equally likely events? If you see the probability computation, in the A option it may not work out for the two options given within A, that is when two coins are tossed, the events of two heads, or one head and one tail and no head. All these things will not be having the same probability. While the B option, the event of drawing a club, which is nothing but 13 by 52, while drawing a spade from a pack of cards, also 13 by 52. So they are equal. This is one of the event which form equally likely events. Occurrence of two heads, the third option, occurrence of no head when three coins are tossed. So the probability for occurrence of two heads will not be equal to the probability of the occurrence of no head when three coins are tossed. So this option is ruled out. The D option says the event of choosing a girl, a boy from a class of 60%. Both will not have uh, the same probability. So the only option is the event of drawing a club, drawing a spade from a pack of cards. So it is the B option, or as given in our PowerPoint, it is the event of drawing a club or drawing a spade from a pack of cards. So B option. 46th question. Mutually exclusive events are also known as, they are known as disjoint events, because the A intersection B, both of the events happening is 0. Uh, so, so also at two disjoint events, their intersection will be 0. So mutually exclusive events are also known as disjoint events. So it is C option, as in the PowerPoint it is C option which says disjoint events. 47th question. If x and y are independent, then variance of x plus y will be equal to variance of x plus variance of y. So we need to have the option A chosen, because the other conditions do not work out. This is as per the concept of variance and its properties. The answer is option A, which says variance of x plus y is equal to variance of x plus variance of y. 48th question. The odds against an event is 4:5. Then we need to find the probability of the event. So the odds in favor of the event would be 5:4. So the probability of that particular event would be 5 divided by 5 plus 4, which is nothing but 5 by 9. So it is D option, that is 5 by 9. Actually it is 5 by 9, it's not 5 by 4. D option. 49th problem. If the variance of two independent random variables x and y are 4 and 6, the variance of 2x minus 3y using the concept of variance of ax plus by is equal to a squared variance of x plus b squared variance of y, we have variance of 2x minus 3y would be 2 squared into variance of x plus minus 3 whole squared into variance of y. Now substitute the respective values of variance of x and variance of y. We get 4 into 4 plus 9 into 6, which is 16 plus 54 equal to 70. So the answer is option D. Going to our PowerPoint presentation, it is option D, which is 70. The last question, 50th question. N dice are thrown. The expected value of the sum of all the n dice is. Now we know that when one die is thrown, the expected value of the variable x would be 7 by 2, which we have already computed. Here when we throw two dice and we would like to get the expected value of the sum of all the two dice, then it works out to be 7 by 2 into 2. Now if n dice are thrown, then we can find out it works out to 7 by 2 into n. So the answer is option D, or as per our PowerPoint presentation, it is option D, which says 7n by 2. As told, it is 7 by 2 into n. If it were 3 dice, it should have been 7 by 2 into 3. So for n dice, it should be 7 by 2 into n, which can be always computed and seen. Thanks for your patient viewing of the video sessions on the topic probability and expectation. For any further doubts or queries, you can always email to queries @greymatteracademics.com. Thanks. Bye bye.